Of the Entomology Graduate Student Organization, I'd like to introduce Dr. David Pimentel. First, I want to thank all the organizations that helped co-sponsor Dr. Pimentel's visit, including the ISU Lectures Program, the Graduate College, the Pesticide Management and the Environment Program, the Leopold Center for Sustainable Agriculture, within the Leopold Center, the IPM, that's Integrated Pest Management Issue Team, the Bioethics Program, and the Center for Agricultural and Rural Development. Lots of organizations, we couldn't have done it without all of them. And this wide range of organizations reflects Dr. Pimentel's wide range of interests. To describe Dr. Pimentel to you, I have to start by describing his scientific credentials, which are pretty extensive. He's currently a professor of entomology, which is the study of insects at Cornell University. 50% of his appointment is in the Department of Entomology. To accommodate his wide range of interests, the other 50% of his appointment is as a professor at large of agricultural sciences, including such things as energy use, soil erosion. This is the only such appointment at Cornell, so someone with an unusually wide breadth of interests. He served as the chairman of the entomology department at Cornell for 6 years. He has authored over 400 scientific and technical papers, including having written 2 books and having helped edit another 14 books. So in other words, this is someone who has really excelled in pretty much all the ways in which scientists measure success. But that's not the main reason why the Entomology Graduate Student Organization invited him to speak tonight. What really distinguishes Dr. Pimentel is his willingness to take risks. And what I mean by that is his willingness to take public stands on controversial issues. This is something that not a lot of scientists will do. It's not necessarily the safest road to professional recognition, but it's something that Dr. Pimentel has done consistently. By his example, Dr. Pimentel shows us that scientists have a special responsibility to educate the public, because it's you, the public, that's going to have to make the decisions about where the balance lies between the costs and the benefits of pesticide use. And we're very pleased to have Dr. Pimentel here tonight to give you some of the information that you're going to need to make those decisions. His topic tonight will be economic and ecological benefits of sustainable agriculture. Dr. Pimentel.
Thank you again for a very kind introduction, and I hope I'll live up to it. I'm going to take one aspect of sustainable agriculture for emphasis, and that's on the subject of pest control, and I will have a few other things in there. But I think it well illustrates some of the problems we have, the challenges, and also some of the opportunities we have to change the system and make agriculture environmentally sound. And I'm going to try to keep this to about 45 minutes so that we can have some time for questions. I will be using slides to illustrate the points that I hope to make. If you could turn those on then. I put this first slide on to emphasize one point that we have. I think we can make out with, I think, the side lights on it. But anyway, is that one major problem and challenge that we have is trying to provide food for a rapidly growing population. And is that the one? This doesn't seem to work. Can you? Either we're disconnected or did you change it or I did?
I changed it.
Okay. Anyway, the world population is 5.5 billion, and we add 250,000 people to the earth every 24 hours, 250,000 that have to be fed, and we already have a problem in feeding the numbers that we already have. 1.6 billion humans are malnourished on Earth today, with 2 billion living in poverty. But even the U.S., did I do that or you did that? You did it, all right. Thank you, I'll rely on you now. The United States in 1850 had 23 million people, or less than the population of New York State today. In 1990, we went to 250 million, and I must admit that my number of year 2070 is incorrect. That ought to be because the world population, since I made this, the U.S. population, since I made this slide, during the last 3 years has increased. It's, both due to immigration and rate of reproduction in the U.S. is now 1.1% per year. And so that should read now, year 2050, that we will have 500 million humans in the United States, assuming they don't increase further. Next slide. Now, our goal, of course, is to produce high quality food in the U.S. and elsewhere to feed people. And the next slide, few people appreciate the fact that the average American consumes 1,500 pounds of food per year, and I've got the calories and the so forth. 3/4 of a ton of food per person per year in the U.S. And the next slide, we should be eating only about 1,000 pounds of food per year, and this shows you where that excess is going. That's part of our National Strategic Petroleum Reserve. Next slide. Now, to focus a little bit on some of the pests, and they do cause an enormous loss to our food system, not only in the U.S. but worldwide. Next slide. Although they're attractive, I suppose, sitting in your corn, it's not of great benefit if you want to save that corn. Next slide. Worldwide, there are about 67,000 pests that share our food, and that doesn't include the rodents or the mammals and the birds. And the plant pathogens obviously dominate the system. Next slide. Now, to try to control these pests and limit their destruction of our food, enormous amounts of pesticide are used. Next slide. 2.5 million tons worldwide, and the U.S. uses about 500,000 tons of pesticide. And one way that we waste pesticide is the way we apply the material. For example, by aircraft, if you're spraying, and I want to emphasize now, this is under ideal conditions, and very seldom do they apply pesticides from aircraft under ideal conditions. Only 50% gets into the target area. I'm not talking to the target pests of the crop, I'm talking in the target area. And the new technology that's being adopted in aircraft application is called ULV, or ultra low volume, and in those cases only 25% gets into the target area. And so the rest of this goes drifting off into our environment to cause problems that I'm going to talk about in a moment. Next slide. Now, the actual amount of pesticide that reaches target pests is less than 0.1%, which means the rest of it is again in our environment, although a lot of this is in the target area, but it's still in our environment. Of course, some of that will move out of the target area in addition. Next slide. Now, in general, pesticides do have a benefit. We in the U.S. spend $4.1 billion annually in pesticides, and it's estimated we save about $16 billion in crops. Thus, for every dollar invested, we get about $4 in return. But I want to emphasize now, that does not include, however, the public health and environmental costs of using pesticides. These are the direct benefits and do not include any of the costs, social or environmental, that are involved in using pesticides. And I'm going to get into that issue in a moment. Next slide. Now, in the U.S., we lose, in other words, despite the use of the 500,000 kilos, the pesticide that we use, we lose 37% of all potential production to insects, diseases, and weeds. And incidentally, the world figure is 35%. Now, the reason, in part, we use a large quantities of pesticide, but still lose, on average, slightly more than the world, is a difference in cosmetic standards. For example, a lot of the fruits and vegetables that you'd see in the Guatemalan market or in India would not be saleable in the U.S. So this is all based on saleable products. And this is in part why our losses are slightly higher than the average in the world. Next slide. Now, some interesting data that indicates some of the problems that we're having, and mismanagement, I'll term it, is the crop losses due to insects. And these are USDA data. In 1945, before we started using the new synthetic insecticides, we were losing about 7% of our crops to insects. And today, am I standing in the way of this projector?
Just the lower part.
The lower, all right, let me stand over a little bit. You can still hear me? Okay, all right. And again, to emphasize, in 1945, when we did not use any synthetic insecticide, that's when we started, and we were losing 7% of our crops to insects. In 1992, after insecticide use had increased tenfold, crop losses, according to the U.S. Department of Agriculture, are now 13%. In other words, nearly a twofold increase in crop losses due to insects, with a tenfold increase in insecticide use. Now, you might say, how the hell could that happen? Well, the reason is, for the most part, changes in agricultural technology. Some changes in cosmetic standards, and their pesticide resistance, and a few other problems. Next slide. And destruction of natural enemies, and so forth. The next slide also illustrates a little bit better using corn as an example related to the agricultural changes in agricultural technology. In 1945, for example, almost zero insecticide was used in corn production. And today, corn is the largest user of insecticides in the nation. Beat out cotton about 4 years ago. Now, next slide. When we started in 1945, most of the corn was grown in rotation, and we didn't have a problem with the corn rootworm complex of insects. And today, about half the corn is grown in rotation and half is not. Next slide. And now, with corn being the largest user of insecticides, there's been over 1,000-fold increase in insecticide use in corn production in the U.S. And again, going back to USDA, next slide, data, that corn losses to insects, according to the USDA, have gone from 3.5% to 12%, with a 1,000-fold increase in insecticide use, and it's primarily due to a change in agricultural technology that is moving away from crop rotations. Next slide. Now, our land is extremely important to us, and I wish I could have spent some time on the soil degradation and soil erosion problem, but I'll leave that for another time. But land is extreme. Next slide. Few people appreciate the fact that 99% of the world's food comes from the land. Less than 1% comes from the oceans and freshwater aquatic systems. And so we should be very concerned about our soils, and the degradation of these soils by erosion and various other means, including highway construction, urbanization, and so forth. And you'd appreciate the problem in part that during a 30-year period from 1945 to 1975 of just agricultural land, from highways and urbanization, we blacktopped over the equivalent area larger than the state of Ohio. That's just highways and urbanization. And if you took all the areas that were blacktop over that period, it would be both Ohio and Pennsylvania. But the agricultural land alone was greater than the state of Ohio. Next slide. Now, when we do apply pesticides, as I mentioned, by aircraft, and especially if they're near housing areas and so forth, you do have this serious drift problem, and the impact of pesticides on the public is significant. Next slide is world data from WHO. The total number of human pesticide poisonings worldwide is about 1 million, with 20,000 deaths. In the US, we also have a problem. Next slide. The human pesticide poisoning, 67,000. It's more than 67,000 each year, with 27 deaths. And the estimated cancer associated with pesticides, about 10,000 per year. So it is a significant public health problem in the US. Not as severe in the rest of the world, but certainly it's important. Next slide. Now we also, when we use pesticides, in particular insecticides, we do destroy some of the natural enemies, and this costs us money. The next slide gives an estimate of the cost to the nation, that's US, in the destruction of natural enemies, estimated to be $520 million, or about $500 million. Next slide. And then pesticide resistance. These are world figures, about 504 species of insects that are resistant, and well, close to 900 total species of pests that have become resistant. And this is a very important problem in the US as elsewhere in the world. Next slide. Oops, I guess I didn't have that number. But anyway, the estimated cost of resistance in the United States is $1.4 billion annually. And this is due to extra pesticides, extra treatments, increased crop losses due to the resistance problem. It's certainly a major environmental problem. And then, of course, pesticides do get into streams and lakes and destroy fish. And this is totally an underestimate, but it would be somewhere in the neighborhood of 30 million. The realistic figure is probably 3 or 4 times that. Next slide. And then when we do use insecticides in particular, honeybees and wild bees are killed, and that is a cost to the apiculturalists, and it's also a cost to agriculture from the point of view of reduced pollination. Wild bees and honeybees are important to pollinating about $30 billion worth of agricultural crops annually. And it's a conservative estimate is that the impact of pesticides on tame or honeybees and wild bees is about a little over $300 million annually. Next slide. And then some other interesting effects that you can get when you're using pesticides is if you use an herbicide, for example, 2,4-D, on a crop such as corn, that it creates other pest problems. That is, it may help control the weeds, but you do create some other pest problems. And these are data on corn showing that with 2,4-D at recommended dosages, that the corn leaf aphid population was nearly 3 times on the treated corn, that is treated with herbicide, than on the untreated. And another, next slide, The corn borers, for example, were significantly more abundant on the treated corn, that is with 2,4-D, than the untreated, and furthermore, these corn borers grew 33% larger on the 2,4-D corn and produced 33% more eggs than the corn borers on the untreated corn. And we also checked it out on two diseases, corn leaf blight and corn smut disease, and both were significantly increased. Well, actually, the corn lost its resistance to southern corn leaf blight when we exposed it to 2,4-D, and the corn smut disease was 5 times larger on the treated corn. Those are the only organisms we looked at. But it does show you the significance of the interaction of some of these pesticides in the impact on pests. Next slide. We'll skip, that's in part some of the changes that we observed. And then birds, osprey and various other birds that do become exposed to pesticides. Next slide. The estimate is that pesticides are causing about $2 billion worth of damage to birds, using a very conservative estimate that I explain to you if you like at some time. Next slide. And then groundwater and well water contamination, and I understand that it's a serious problem here in Iowa also. It's estimated that if we did an adequate job of monitoring well water and groundwater for pesticides, that it would cost the nation $1.3 billion annually. Now remember, that's strictly monitoring. It's not doing anything about the problem. Next slide. And then, of course, pesticides do reduce species diversity, and it's estimated worldwide that it's not just due to pesticides, but due to all the factors such as removal of forests, that we're losing about 150 species per day due to our various changes that humans are causing. Next slide. Now, the total environmental costs of using pesticides, back to the United States, we estimate to be at least $8 billion, or another way to put it, more than $8 billion annually. So it is a significant cost. Now, pesticides still are beneficial in terms of economics if you factor that in on the cost benefit. Originally I told you that you get $4 return per dollar invested. Well, if you would factor even this $8 billion, now I realize that this is a conservative figure, this $8 billion, but if you factor it in, it still turns out that pesticides are a net benefit for the nation. Now I'd like to turn, next slide, to what we can do in managing our pest control technology to improve it and hopefully make it more profitable. Next slide. And the basic principles that I have related to sustainable agriculture is that we make maximum use of our biological resources and to minimize our energy inputs in the system. In other words, actually minimizing our management of these resources. Next slide. And related to sustainable agriculture, in one study that we made, it does take more labor, especially if you're going to make use of livestock manure in the recycling in the system. And that is one major problem in the U.S. is that we're not making effective use of that manure. It is polluting our water, it's polluting our surface waters, and wasting a very valuable resource. Next slide. And we can conserve fuel in this particular model situation related to corn. We are able to, by being selective of the tractors and the equipment that we had, reduce the total fuel input from 115 liters per hectare to 70, a major, well, about 40% reduction in fuel inputs. Next slide. And then our actual corn yield in this particular system, we were actually able to increase the yield in the sustainable system. We were using a crop rotation system here, and so that we were able to get a higher yield and with no insecticide being used in this particular system. Next slide. Now, as far as energy goes, we were able to, in fact, reduce the total energy inputs by 1/2. That is from 7.8 million kilocalories per hectare to 3.7 million kilocalories per hectare. Reduce soil erosion from 20 tons per hectare to 1, and obviously reduce the water runoff and reduce the amount of pesticide being used in this particular system. Next slide. Now, dollar-wise, it was also the cost of production were reduced from $523 per hectare to $352 per hectare, and that does include the additional labor, the 20% more labor that we had in that system. Next slide. Now, related to pesticides, 4 countries, if you include Ontario and Canada as a country, have made the decision to reduce pesticide use by 50%. And Denmark was the first country to do that, and Sweden the second. And Sweden in 1992, or last year, had already achieved their 50% reduction in pesticide use, and this year they've implemented another program to achieve another 50% reduction in pesticide use. Well, what we did at Cornell was to make a study of, I think it was 40 different crops, and all of the non-chemical technologies that exist, and then examine and ask, well, 2 questions. Could we in the United States implement a program to reduce pesticide use by 50%, and how much would it cost? And that's what technologies we already have available, similar, of course, that Sweden or Denmark or Netherlands are implementing. Next slide. Well, skip next one. Now, one of the things we want to do, of course, in you're trying to reduce pesticide use is make better use of your natural enemies, such as this aphid lion that you see here. Next slide. And that makes making judicious use of pesticides. This is the potato beetle, and using crop rotations and short season potatoes. Anyway, there are a lot of different technologies that we can use to deal with some of these serious pests. Next slide. And I'm not talking about total elimination of pesticides. I'm talking about reducing the amounts that are that have to be used through implementation of non-chemical controls and through the judicious use of pesticides. And crop rotations are a benefit not only to insect control, but diseases and weeds, and obviously help reduce soil erosion and soil degradation. Next slide. And then, of course, one weapon that we have in pest control against insects is using some of the diseases that affect them. On the slide here, you see the one on your left, the caterpillar on your left, is a healthy cabbage looper. The cabbage looper on your right is the whitish one, is full of virus crystals, and these virus crystals look like sugar crystals under the microscope, and that animal is totally packed with virus crystals, and it's a highly pathogenic virus. If you take 2 caterpillars, well, such as the next slide, 24 hours later, this is the caterpillar, obviously quite ill. And if you just take 2 caterpillars like that and mix them in 100 gallons of water and spray it over an acre of land, you can kill 98% of the cabbage loopers that are present there. So it's a very effective, highly pathogenic organism. Unfortunately, even though every one of us in this room has eaten the virus in our coleslaw or lettuce and so forth, and not affected us, or at least not that we know, EPA has still not approved the use of this virus yet. Next slide. Now, there are a lot of, and I'm not going to go through all of those, that's just a list of some of the non-chemical controls that are available to us that we can use and implement to reduce pesticide use. And there isn't any one of them that is perfect, and what we should be doing is being very selective and using those that are most appropriate. And I guess that what Professor Pettigo said is very appropriate. There is no silver bullet for pest control, and we ought to be using combinations depending on the particular situation, the pest and the environment, the crop, and so forth. Next slide. But it does illustrate the complexity that we're dealing with. And this is a shot in Kansas that the late Professor Painter provided me, showing you wheat on the right here that's susceptible to the Hessian fly, and wheat on your left that is resistant to the Hessian fly. And so this is one more technology that is available to us and can be used effectively depending on the crop, depending on the pest, and so forth. Next slide. Now, well, skip that one, the next one. Oh.
That's the last one.
That's, well, anyway, I know what I hope to be my last slide is that we could achieve a 50% reduction in pesticide use in the United States. You can turn the lights on. And without a reduction in yield, without a change in cosmetic standards, and that we could do this with an increase in food prices of only 0.6%. Now, I want to also emphasize that this calculation of a 0.6% increase in food costs, implementing a 50% reduction in pesticide use, does not include the benefits of public health, of reducing pesticides on public health, or reducing pesticides on the environment. If you take into consideration those benefits, then of course, in general, there should be a net benefit to society by reducing pesticide use by 50%. And it can be done, I'd say, one country has already achieved their 50% reduction, and 3 others are well on their way to achieving this 50% reduction. So this is not something that is pie in the sky. I'd be happy to answer questions well, I guess we got quite a bit of time, don't we? Go ahead. Any comments or questions? Yes, sir.
Seems to be a great deal of controversy surrounding the effects, especially of organophosphates, on workers applying these. Have you done any work in this? Do you have any knowledge in that area specifically as to health hazards, etc.?
Nuts, all that well, there are 2 bits of information. In Central America, where we were working on cotton, of course, I was going to say the workers were careless. I should really put it the other way around. That is that the managers of these farms were very careless. They sprayed these workers while they were in the field. They allowed the field workers to go into the field to pick cotton or weed right after the fields had been treated, and so that they were getting wet with the pesticide in there. And that, of course, we don't do in the U.S., but even in the U.S., right after DDT was banned and there was an increase in parathion and several of these other more toxic materials, there was about a 3-fold increase in the number of deaths in the U.S. Now, one has to say, if we were careful, there shouldn't be these deaths because we know how to handle it safely and so forth. But of course, accidents do happen, and in Central America, we also would know how to handle it, but it's not being done. And I'm not just blaming Central America. I mean, this occurs elsewhere. I mentioned Central America only because we worked there for a while. Yes?
With regard to reducing pesticide use by 50%, I'm just curious, are you referring to that on an active ingredient per acre?
Yeah, that's active ingredient per acre, and of course, you know, that has problems because I know in Sweden and some of these other countries, they did shift to some of these more toxic materials that you can apply, for example, ounces per acre instead of pounds per acre, and so that's cheating a little bit. But there's no good way of measuring, but that's what we did. But we did not substitute more toxic materials we were strictly using the same materials, either reducing the dosages or reducing the times treated or totally eliminating some of the treatments, but we did not use more toxic materials to achieve this 50% reduction. We could have done that. Yes?
One of those points that should be made though about the reduction of cotton versus corn,
Yeah.
wasn't part of that reduction due to the shift of pyrethroids, which are very much more active, and that's been held up as a real reduction when it really, in terms of amount of the frequency and so forth, is still there. It's just that the material is more active, so it appeared that there was a reduction. When in corn, we haven't gone to the pyrethroids, so really,
Yeah. It's
I'm
not
not sure that cotton has gone
Yeah.
down relative to corn.
No, that's a good point. And pyrethroids have their problems environmentally. Yes?
How much of an impact, or like a strain would you put on the farmers when they make that shift from pesticide use to less pesticide?
That's a good question.
Insects to control or whatever.
Yeah, to make the shift, yeah, you couldn't do it overnight. Well, I'd say in general, sustainable agriculture is more knowledge intensive than regular conventional agriculture. So it takes more knowledge. Really, you're substituting knowledge for chemicals. Now, to do that, of course, it means that you've got to train people to use this new knowledge and new approaches, and that would take time to achieve. As I say, Sweden did it in 5 years. Some of the other countries have plans to do it in about 10 years. But it's not substituting alternative technologies for chemicals will take training and knowledge. Definitely. Yes?
Do you see any trade-offs with more fertilizers need to be applied or more energy-intensive agriculture with that 50% goal?
The trade-off?
Yeah, are there any other environmental trade-offs, such as increased fertilizer use or
No,
energy
no,
intensive?
no.
Really? Great.
There would be no increased fertilizer use. Now, we did decrease the fertilizer use in that sustainable system that we had there through use of, well, first of all, keeping the soil in place, that is, preventing 20 tons of soil being lost from the land. And you know, each ton of soil has about 4 kilos of nitrogen plus other nutrients. But making use of livestock manure in that particular system. Now, it did cost us in labor, of course, to do that. But as far as reducing the pesticides, no, there was no impact on the fertilizer use in any of this, and without any reduction in yield.
Any increased energy use?
And no, I would say that on corn there was decreased energy, but I wouldn't want to say that for all the other crops because we never looked at it. You have to really look at that crop by crop. In general, I would guess that it wouldn't increase the amount of energy, but I wouldn't want to say that it decreased it either at this moment. Yes.
Well, I think of Sweden and Denmark as being sort of progressive, advanced kinds of civilizations. And I think about the U.S. and I don't see it in the same way. Do you think that the climate is changing enough in this country that such a 50% reduction can be mandated by the USDA?
The question here is, Sweden and Denmark appear to be progressive, and will we ever in the United States achieve this type of a change? I think we will, but if I look for the banning DDT as the model decision, then I would say it'd take us 10 years after Sweden to get to the point where we will make a similar decision. But I think the climate is certainly coming. And remember, this change in Sweden and Denmark, or Netherlands, or probably Ontario, did not come from agriculturalists or entomologists. It came from the politicians listening to the people. Now, already in the United States, in a survey by Food and Drug Administration, I don't know whether it was 97 or 96%, somewhere in that vicinity, of the public are concerned about pesticides in their food today. And so that there is this growing concern, and the credibility of EPA has dropped significantly during the last 20 or 30 years. And so there is this climate and pressure to try to do something about it. And certainly once we see the success of Sweden and Denmark, and Norway too, although they haven't passed legislation, but they're certainly well on their way, and the Netherlands and the province of Ontario, and incidentally in Ontario, the specialist who's in charge of reducing, is implementing the program to reduce pesticide use, I thought the farmers would be resistant to this, and he told it's opposite. He said the farmers are highly supportive of this whole program to reduce pesticide use, and he said there are 3 reasons. 1, pesticides cost them money. 2, they're the ones that are applying these toxic materials, and they're being exposed, their families being exposed. And 3, they also have a concern about the environment. I must admit, I didn't expect this, and I'm not talking about all 3, not just the last one, but they're really highly supportive of this program up there in Ontario. Now, I don't know about Sweden and Denmark. Well, I never asked a question there. Someone else had a question. Yes, sir.
Your use of the word pesticides, does that include herbicides or not?
Herbicides, insecticides, and fungicides, right. And the actual reduction that we looked at in our paper in achieving this reduction, we could achieve the greatest reduction in herbicides, second in insecticides, and least of fungicides.
Well, I'm sure you're aware there's been some interesting work done in this state on lowering the use of herbicides through changing techniques. It seems to me that a generation ago, when people rotated regularly and many of the other, what I term more common sense practices were still used, what do you see as the big reason why people don't consider that more as a real option, especially when it's cheaper?
Well, you have other people here that know more about Iowa than I do, but you know, price supports has played a very important role in reducing crop rotations, and it's also played a very important role in separating livestock production from integrated with grain production. And so there's a whole array in the marketing orders as far as changing cosmetic standards, not that that's important in grain so much, but there's been a whole array of factors that the government, I'm talking about federal government, has played a very important role in encouraging soil erosion, encouraging fertilizer use, and encouraging pesticide use. And so one first step would be to get the damn government straightened out and supportive of sustainable agriculture and reducing our reliance on chemicals. And that would be the very first step. And let me indicate again, I think we could go beyond a 50% reduction if you will allow changes in price supports and deficiency payments and marketing orders, and you also allowed us to use pesticides at dosages that are effective instead of using the labeled dosages on the can. And I mentioned this afternoon. I have one of my past students in Norway who's working with fruit, and he has demonstrated clearly that in using certain insecticides, that using 1/5 or 1/10 the dosage that's on the label, he can get more effective control. And I want to emphasize more effective control, because he can save the natural enemies and make use of them in the pest control system. So now if you let me do some research and determine the appropriate dosages, we could go further in that reduction. If you allow me, all those changes, cosmetic standards, marketing, price supports, and getting the appropriate dosage, I think we could go to a 70 or